Okay, so this time we're going to be looking at another volume of revolution, except for this time we will be using cylindrical shells. And you'll see why we need to use cylindrical shells in a moment. So this time we're taking the curve y equal to 2x squared minus x to the 3, and we're looking at the region bounded by that curve and the curve y equal to 0. So that's this region right here. We'll be rotating that around the y-axis, and that will be forming our three-dimensional shape. So in this case we end up with sort of a strange looking bowl, and this is going to be the thickness of the bowl as it goes around the y-axis. And so really we don't need to draw in the three-dimensional image. We'll be doing everything this time from the two-dimensional image. But first we want to look at why we need to use cylindrical shells rather than discs. So for discs and for washers, we know that we're going to be doing horizontal cuts perpendicular to the axis of rotation. So in this scenario, that would be a horizontal cut, so that we would be working with respect to y. Thickness of that cut would be delta y. Now, what's the problem with that? Well, if we're going to be doing our cut with respect to y, then we need to take this right here, our curve, and solve for x in terms of y, and that is very much what we would like to avoid. Okay, so we would much rather work with y in terms of x, which means we would much rather do a vertical cut, except that when we do a vertical cut here, yes, we end up with a thickness of delta x, but we do not end up with a washer, we do not end up with a disc. If we take that cylindrical shell, if we take that vertical cut and rotate it around the y-axis, what we will end up with is a cylindrical shell. So if we go over here, let's picture what that cylindrical shell would look like. And so again, we know for our cylindrical shell that the thickness of the shell is going to be given by delta x, so we can label that right here. That's going to be our thickness, delta x. The other things that we are interested in, that's going to be this right here, our height, and we know that we are interested in this as well, which is going to be our radius. Okay, so looking back at our image, we want to know what's the radius, what is going to be the height. And for us, the radius is always going to be the distance from the outside of the shell to the axis of rotation. Again, the axis of rotation going right through the middle of the cylindrical shell. So that's going to be this distance from here over to here, and that's going to be a point on the curve. So that's going to be our radius. This point having coordinates x, y, that distance will simply be the x value of that point. So for us, the radius is just going to be x. And we notice that's good. Our thickness was delta x. We want our integral to be in terms of x. Our radius is just x. So that's going to be easy. One of these two, the radius or the height, will be easy. The other one's always going to be more complicated. So that means in this scenario, the height is going to be the more difficult one. We notice here on our shell, that's our height. So over here on our image of our region, this right here, that's going to be our height. And for us, the height will be the y value. So yes, over here, the height is the y value of that curve, but we know that's not a good thing. Our thickness is delta x. This should be in terms of x. So what is y equal to in terms of x? And we have y is equal to 2x squared minus x to the power of 3. So now we have our radius, we have our height in terms of x. And so great, our volume is just going to be equal to 2 pi. We are going to integrate radius multiplied by height from a to b. And our radius is x. Our height is 2x squared minus x to the power of 3. We're integrating with respect to x. And then here, what's the smallest value of x and what's the largest value of x? That's going to be here 0, and that's going to be over here are the intersection, or the x-intercept of this curve. So if we solve when is 2x x squared minus x to the power of 3 equal to 0. We end up getting when x is 0 or when x is 2. So that's here 0, that's one of our x-intercepts, the other one over here is at 2. So we have lower limit of integration is 0, upper limit of integration is 2. And so this right here is going to represent the volume of our object, and what we end up getting for this total volume, if we did FTC2, you'd end up with 16 over 5 pi. And that's it.